storm that starts out as a blustery day swells and joins with others to smother the planet. A blood-red dirt cloud races and rages, obscuring the sun. Twisting pillars of powder-fine dust blast the surface, spinning at over 160 kilometers an hour. It's just another day on Mars. But this alien weather would suffocate life on Earth. The wildest weather lies in outer space. On planets like Mars, where high winds fill the air with talcum-fine powder. It's a world overwhelmed by dust and ruled by dust storms that can choke the red planet for months. So imagine what would happen if a Martian dust storm hit Earth. Clues about the Martian storm's earthly version are found in unlikely settings.
Yeah? Yeah? There's a rabbit on the track. Oh yeah.
More than 3 kilometers above sea level in the Swiss Alps, William Broughton is on the track of a dusty mystery. On Darwin's legendary voyage of the Beagle, almost 200 years ago, a fine reddish-brown dust fell on the ship. She was far out in the Atlantic, nearly 700 kilometers from Africa. The dust made the atmosphere hazy for weeks, and Darwin was intrigued. He later uncovered 15 separate accounts of similar mysterious dust falls on ships far out in the ocean, dust that hurt the crew's eyes, dirtied everything on board, and obscured the horizon. He suspected it was coming from Africa, a cloud of dust traveling around the world. Darwin's observations resonate with Broughton because he has also found African dust in the unlikely setting of the Alps.
Very often in spring, here you can wake up in the morning and your car is covered in, well, sand more than dust, very fine sand. It looks as if you'd been parked on the beach on one of the coasts of America and you'd gone out after a nice day of surfing and your car is covered in sand.
Broughton is a dust expert, a microbiologist in Geneva. The area's crisp snow and alpine ice make a perfect living laboratory for his work.
This is an air sampler. We have to change it so we can collect another sample.
His isolated research station is high above human contamination, a pristine environment where dust is captured straight from the atmosphere.
At this altitude, there's very little contamination. So here, and only here, because of the research station's facilities, we're able to collect dust under conditions that get as close as possible to sterile.
Forensic analysis matches the samples with dust from other places.
We can make a kind of a fingerprint. We can fingerprint this dust, match it to fingerprints of dust from other places, and say, this one has the same fingerprint as dust that starts in Chad, therefore it came from Chad. It's an event that occurs here in spring and in autumn, every year almost in the Alps, and in the lower regions of Switzerland too, you will see the snow covered in dust. It can be red, it can be orange, and so on, showing its African origins as well.
Dust from Chad in north-central Africa, trapped in this alpine setting, just one of its many destinations around the world. In the mid-90s, scientists using satellite data discovered just how much dust could travel the globe. Sophisticated weather tracking technologies spotted a mass of dust 700 kilometers across. It was a colossal dust cloud that crossed the Atlantic in less than a week. A phenomenon our blue planet shared with another, the red planet, Mars. When the first pictures from Mars were received in 1971 from Mariner 9, there was little to see. Mars was consumed by a dust storm. The storm raged for a month, then abated to reveal a lifeless desert world. Martian storms can start anywhere on its surface because everywhere is dusty. But on Earth, much of the dust in our atmosphere comes from one valley in north-central Africa. It's the dustiest place on Earth, the Bodele Depression in Chad, in the Sahara. Every day, the Bodele produces more than 600,000 tons of dust. The steep sides of its valley act like a giant funnel, channeling dust up into the atmosphere, where easterly trade winds spew it around the world. But a Martian storm starting here might churn up millions of tons of dust, a month's worth in a single day. A Martian dust storm would kill life on Earth. But dust from the Bodele supports life on our planet. The Amazon relies on nutrient-rich dust from Africa, over half of it from the Bodele, about 18 million tons a year. So if life on Earth depends on dust from Africa, we need to understand the mechanics of its transport, in case it ever breaks down. The scientific holy grail is how the dust gets off the ground in the first place.
They don't come to us, we have to go to them. The first time I saw one, I was pretty scared. Yeah,
Matt Baum is a research scientist with the Planetary Science Institute. He's working on a NASA-funded project with PSI's Steve Metzger, a planetary geomorphologist. They're in the Mojave Desert outside Las Vegas, chasing mysterious phenomena that the Navajo Indians traditionally think of as malevolent forces. Natso Oldisi, better known to science as dust devils.
Okay, we've got a plane in the air with thermal and visible cameras.
Wind sensors, pressure sensors.
We've got my direct sampling of the truck with all kinds of pressure and temperature.
We've got a little remote rapid rover.
There's a LiDAR truck. There's a bunch of weather stations surrounding the whole area trying to get boundary layer, three-dimensional winds and its turbulence.
Measure wind speed and direction from, a kilometer away.
We're trying to study every aspect of this all at once, from every angle we can.
In 1997, Metzger was a doctoral student at the University of Nevada in Reno. It was the year Pathfinder touched down on Mars, and Metzger soon spotted something in the pictures it sent back. Columns were visible on the Martian horizon, dust devils that could be seen clearly in subsequent footage. They were just like their earthly siblings, but on a massive scale. Whenever dust storms are observed on Mars, dust devils are often present, leaving long, dark, telltale trails on the planet's dusty surface.
It looks like a tornado, so instinctively you're thinking, it's a tornado. Everyone feels pretty embarrassed after they crouch down and hide the first time.
Not everyone does that. So the Dasher rig has pressure sensors at the ground, the mid-level, and up top. We've got wind speed at all 3 locations. Got a complete weather station here. This is a infrared thermometer, and its goal is to look at a really dusty dust devil and see the temperature of the dust in midair, which is surprisingly hard to measure temperature fast in a hostile environment like this. It has to survive all kinds of rough stuff. Alrighty, I'm gonna go for this one to the west here.
Temperatures on Mars are much colder than the desert, and the red planet's air is much thinner. But it's the temperature differential between ground and air that fuels dust devils on both planets.
That was waypoint 79, a direct hit, 1 meter wide. A real nice one due north, but way off grid. Yeah, way off grid.
The team wants to understand the physics and meteorology that underpins dust devils. If they can work out the devil's mechanics, it could also reveal its function.
We have giant dust storms on Mars, but in between those dust storms, the atmosphere is still really dusty. And there's no real reason why that should be the case. So we think dust devils are that missing link. They're like the workhorse of the Martian climate, keeping that atmosphere dusty at all times.
They're tracking wind speeds and directions, temperature and humidity, atmospheric pressure, and the amount of dust in a devil.
We're really trying to study this from every possible angle because we understand some things and we're using that to test the models to explain dust devil activity. And there's other stuff we don't yet understand or we haven't yet discovered or seen. So we're trying to do everything we can to find out what we know and what we don't know.
The heaviest particles, the large sand grains and clumps of earth, they stay near the bottom. That's why it looks most dusty there. But the very fine dust gets caught up in that upwelling column where the wind speeds are moving upwards. And that's why you can see this fine column up at the top there. And you see near the bottom, there's like a sand skirt. And we generally call that the skirt. And that's where the sand-sized stuff is. The higher stuff that can go up kilometers is very fine.
Some have a very clear core. Some have no core. Some look ropey. Others are very clear cylinders within cylinders within cylinders. There's layers of dust. There's layers of dirt spinning around, all vertical cylinder layers. It's very interesting. Some have ejecta skirts of debris and dust and mud flakes out the base. Some are very gently wafting you. Others just bombard you.
But under attack, they fight back with a special souped-up boy's toy called
the Desert Surface Thermal Buoyancy Nadir Experiment, or Dust Bunny. And it's allowed us to get in and out of dust devils repeatedly and sample the pressure, which is a crucial thing we need to measure. And by getting into it and sampling that pressure, even with this rig's mobility, I'm often missing the direct core, and it takes a certain amount of luck and tenacity. So if you just keep going back and forth, that little instrument package, taking pictures, it's getting GPS altimeter data, it's really turning out to be a very helpful little unit.
There we go, we got it. Sweet. Well, do you want to get the computer out? We can download this right now. The only problem is it's a little fragile, so we have to be careful when we're driving it. At the center of every dust devil appears to be a low-pressure core. And some people think that low-pressure core can help to suck up extra dust as well as the swirling winds. There's like a suction effect as well. I mean, it'd be nice to be able to prove that one way or another. Hopefully this will help us do that.
This puppy's holding up, isn't it?
Yeah, it's doing all right.
On Earth, dust devils range from puny spinners a meter wide to their big brothers 100 meters in diameter. But on Mars, they can be 5 times as wide and tower 8 kilometers high.
That's a pretty good one. That's a good one.
Then the team spots an infant that they reckon is poised to grow into a giant.
That's a big boy.
And Metzger finds himself facing the biggest dust devil he's ever encountered. A monster dust devil of Martian-like proportions, advancing to battle NASA in the Mojave Desert. This one could hold all the secrets they seek.
This dust devil is very intense. It's really amazing. Look at this thing.
Oh, I'm still in it. That was wild. Did you see that thing? That was intense. That was the most intense dust devil I've seen. It was like flinging tons of stuff. It was totally dark brown inside there. It was amazing. It was like dark brown. So it was intense.
On this field trip, we've managed to get some thermal images of dust devils, and this is really exciting. We've got images from the air and images from the ground. We can see the core of the dust devil really well defined. We can see the structure perfectly. When we get back to the lab, start analyzing these data, I think it will tell us a lot about how dust devils form.
My God, I can't see anything. That was fantastic.
Dust can turn up the heat in the Martian atmosphere by up to 30 degrees Celsius. This could be a clue to why Martian dust storms grow so big. The hot air rushes to colder regions, generating winds that stir even more dust. A self-sustaining cycle. On Earth, water is a coolant, helping stop dust from turning up the temperature. But our dust storms can still travel enormous distances. In the mid-1990s, a NASA team were mapping the Earth's ozone layer. As an experiment, they retuned their satellites to focus on fine dust particles in the Earth's atmosphere. They were surprised by the sight of a gigantic cloud of dust 700 kilometers across, heading straight for the Americas out of Africa. The Martian dust storm that's playing out on Earth is also leaving Africa. Some of the dust traveling north from the Sahara into Europe, and some of it west across the Atlantic. As it crosses the ocean, it blocks out sunlight that could warm the waters to a hurricane heat. And it's no coincidence that years with lots of dust storms are also years with fewer hurricanes. That's a good thing for air travel, but dust storms can bring their own problems. Because if a hurricane is just starting to churn above the ocean, when a dust storm arrives on the scene, they can collide.
没想到可以买新车，那个
That down for you. Sorry. Apologize for that.
The dense, swirling cloud of ultrafine dust particles is in super dry air that crackles with static. The huge superheated hurricane wind is full of moisture and pumped with energy.
I just asked them to strap in. I don't know how bad it's going to get. Thanks.
Two weather super systems in a frightening standoff. One will be eliminated.
Sorry, ladies and gentlemen, we're just going through some turbulence, some light turbulence. Okay, everybody keep seated, keep seated. Seatbelts on, fasten your seatbelts. Okay. Seatbelts on, seatbelts on.
This time it's the dust storm that wins, suffocating a smaller, less developed hurricane, then moving on.
Everything's gonna be fine. Keep your seatbelts on.
dust storms on Mars and Earth can have global reach and influence the weather. But on Earth, they also affect life itself. In Florida, the stunning sunsets caused by airborne dust are a vivid warning that the asthma and allergy season is about to hit. The cause links back to Darwin's dust and to the Alpine laboratory where William Broughton has written an amazing footnote to one of the most famous expeditions in history. High in the Swiss Alps near Geneva, a glassy underground labyrinth has been carved out of the mountain. It's a scientific ice palace that houses a very special collection of dust. African dust that once fell on the snowy mountains of Switzerland is now trapped deep underground.
Ah, Felix, this is the layer you were telling me about, no?
Yes, this is a layer of sawdust they put down in 1947, which was a very hot summer. So they used this sawdust to protect the glacier from melting away too fast.
The sawdust layer marks the surface of the glacier in the middle of the last century. It provides a base mark that enables scientists to date the dust layers around it.
That's 47, this layer's 48, this is 49, here we got 46, 45.
You can date your samples.
Broughton is a microbiologist, a reanimator who sees potential life in dust.
This dust that was trapped, first of all, on the surface of the glacier, and then as each new snowfall buried it further, the life in this dust has remained living and can be resurrected, reanimated, using standard microbiological techniques.
Broughton's dust is frozen in ice, a kind of suspended animation. Particles from Africa trapped where they fell many years ago. But Broughton has obtained a sample of the dust collected by Darwin on the voyage of the Beagle. Dust kept in a glass capsule with handwritten notes. The dust was collected in 1832, and Darwin later noted it carried microbes. Now Broughton wants to know if they're still alive.
First of all, getting dust that Darwin himself had collected was exciting. I mean, it's theoretically possible that there's some of Darwin's DNA in this dust, right? Second, when you have the dust and you're able to show that it contains lots of different living things, for scientists, this is as good as it gets.
Broughton and his colleagues are able to confirm Darwin's hunch that his dust came from the Sahara. But their forensic fingerprinting goes further and pinpoints the dust source as the Bodele Depression, over 4,000 kilometers distant from the Beagle.
Sterilize the filter.
And then they find something even more amazing. There are microbes still living in the dust that Broughton is awakening.
We like to call the microbes as hitchhikers on dust that is carried from continent to continent. And they land again, for example, in the Amazon, often in rain. And they germinate on soil or on leaves or wherever they do, and start a new life cycle in a new place.
Darwin believed a species originated in a single place, then spread as far as it could by any means. His dust is evidence of one of them.
I've never thought of dust as being inanimate. There's life in Darwin's dust that means, in one sense, very little has changed over centuries.
Our Martian dust storm, teeming with microbes from Africa, is rapidly spreading, closing in on North America. On the ground, it's brownout, a fog of dust and sand obscuring visibility, nightmare for vehicles. High in the atmosphere, the particles are smaller, lighter, as fine as cigarette smoke. All invasive.
That's terrible. That's really bad.
A serious threat to any craft in the air. A dust storm that beats a hurricane must be bigger and more powerful than its foe. Its winds are racing at 160 kilometers an hour. Super dry air sucking up solar energy, fizzing with static. Discharging electricity into everything in its path. An enemy that's invisible until it invades. By which time, it's too late. Dust destroys technology. A nightmare waiting to happen on a manned mission to Mars. NASA is spending millions preparing for human exploration of space. Technology that can be tested in dust storms on Earth. No one takes the dangers more seriously than Pascal Lee. Lee is the chairman of the Mars Institute. He's a planetary scientist at the Search for Extraterrestrial Intelligence Institute.
Reverse planning meeting.
And director of NASA's Mars project in the Canadian High Arctic. His lifelong quest has been to prepare for human exploration of the Red Planet, a journey he'd like to be on himself, if his canine companion can go with him.
Ping Pong is my dog, and she's an incredible life form. If somehow I had a chance to go to Mars, one of my first thoughts would be, well, would I be able to go with Ping Pong?
Humans have long been fascinated by life on Mars, but Lee's mission is to protect us from it by keeping out the dust that could be carrying it. He's testing a new spacesuit that NASA hopes will withstand a dust storm, whether it's on Mars or Earth.
The thing about expeditions is that they're won before they happen. They're won in the preparation stage. They're won when you retire risk. And what we're doing here is part of retiring risk. We're trying to understand the types of obstacles that humans will encounter and find solutions to mitigate against these dangers.
Martian dust is powder fine, abrasive and irritant. It's potentially highly dangerous, likely toxic, and the strong oxides it's thought to contain would burn the skin like bleach.
What we're interested in here is to understand the impact that dust could have in our ability to explore Mars safely and productively.
Lee hopes this could be the answer. NDX-1, a prototype Martian spacesuit designed by researchers at the University of North Dakota. It's the only one in existence, and it's about to be tested in a unique experiment.
Today's test is to look at what happens to a pressurized spacesuit when it is subjected to a dust devil, be it on the Earth or on Mars. And what we'll be looking for is how and whether dust grains adhere to the surface of the materials that we have on the spacesuit, and also whether this dust infiltrates the suit itself.
As a child, Lee dreamed of space travel to Mars. This baptism of dust marks another step on the way.
Feels like a very tight dishwashing glove all over your body. Very rubbery inside, but it's a snug feel. The whole body's comfortable here, but the fingertips are hard to match up as you insert it like this. It's a little bit toasty in here, but it's fine.
If you're ready, we can get you with the helmet and pressure the suit, and then what we'll do is get you the backpack, and we'll be ready to go.
Okay.
Mm-hmm.
The vortex awaits. But that isn't the only test the NDX-1 must face. The NASA-funded prototype Martian spacesuit is given a substitute astronaut before it's subjected to an extreme earthly dust storm in a specially designed wind tunnel. A stream of intense particles batters the prototype as the scientists watch in the hope that their suit will protect and defend. The team simulates the irritating dust of the storm with finely ground walnut shells and fuller's earth, better known as kitty litter.
I've almost complete loss of visibility here.
Martian dust is as fine as talcum powder, potentially deadly if inhaled. building up static and challenging the tightest seams.
I was just amazed by the dynamics that was going on here, the intricacies of the vortices, of the eddies that were picking up this loose material on the ground. Looking up into this column of dust was just, you know, amazing.
Lee is happy with his mission, but after the Mannequin's air tunnel test, the NASA scientists make a sobering discovery.
We can see dust in the joints. That's really the spacesuit maintenance nightmare. So what would you guys say is your first initial conclusion?
I think the bad news is as much dust as got through here. I'm a little worried that in time, this could grind into the fabric. It looks to me like I said, like quite a bit got through, infiltrated through the blue layer.
Should be quite a bit of dust still inside the arm.
Dust wins again. The mission must continue. NASA knows the challenges from past experience. The men who went to the moon were plagued by lunar dust that attacked their layers of boots and suits, invaded living quarters, and irritated their eyes and lungs. At least one astronaut came down with a bad case of lunar hay fever. The alien dust was something none of them would forget. For Buzz Aldrin, those memories are vivid. Aldrin is one of the first and few to walk on alien soil. For a couple of hours on a day in July 1969, Aldrin took a stroll on the moon with fellow astronaut Neil Armstrong, and what he found underfoot was like nothing he'd ever seen before. But it did have a familiar scent.
It had an odor, burnt charcoal, like a fireplace. It was very fine, and of course, it left a very remarkable print of our boots. And it behaved in a way that just something I'd never seen before. You put your foot down, and as you do, you displace, and it all leaves at about the same angle. And it all goes out, and then it all lands in a semicircle. It doesn't do that here.
Remember the old films, and you see them, the guys walking on the moon, and you see them bouncing around and so forth.
Well, I was doing that. I was strapped. One foot after another, and then I tried the kangaroo hop.
It may look like an unlikely partnership, but Dale Griffin is a microbiologist with the US Geological Survey, and Aldrin is helping him hunt for the Sahara under the Caribbean Sea.
All right, we're ready.
Coral here is dying, under attack from some form of microbe. Griffin believes it's carried on the wind, in dust.
Stand up.
I appreciate the macro impacts that the micro world can have through the transportation systems that the climate has in the way of atmospheric wind transport.
For Aldrin, being underwater is second nature. He prepared for weightlessness in space by training underwater.
In an inflated pressure suit, astronaut Edwin Aldrin, pilot for Gemini 12, is weighted with 60 pounds of lead. He is positioned at the Preparedness workstation by trained scuba divers.
Today, he's more aquanaut than astronaut, and finds that water doesn't stick like dust.
What we're trying to do is match like species of bacteria, fungi, and viruses. So we're trying to show links between what's in the atmosphere when African dust is present and what may be on the surface of these corals.
Coral reefs all over the world are in crisis, the victims of pollution and other forms of human activity. Griffin believes he's on the trail of another killer, virulent strains of microbes hitching a ride on seasonal dust falls. Coral has a sticky layer of mucus on its surface that traps particles and microorganisms in the water.
See that buzz? How it's broken down, all that tissue loss there? But obviously he's infected. What we're looking for are, where do they come from? These clouds of dust that come over from Africa in the summer impact the entire Caribbean. That about 20 to 30% of the organisms we find in the atmosphere when African dust is present are pathogens, known pathogens of some type of microorganism. Those phenomena has global scale consequences. So I'm going to grab a piece of tissue on this disease tissue right here.
I can't resist using the phrase ashes to ashes and dust to dust. Wherever we find it, we better understand how it got there and what is going to cause it, because it's a transported item that's going to move things, good or bad, from one place to another.
Lab analysis of Griffith's samples confirms that a fungus commonly transported in dust is infecting the diseased coral. It's a fungus he's seen before, in dust from Africa. A Martian dust storm that started in an African valley is about to hit the eastern seaboard of America. Dust devils are already stalking Manhattan, filling the streets, dwarfing skyscrapers, stretching to the horizon in every direction. But for many, still going about their everyday business, the storm strikes without warning. The approaching wind is whipping up the dust that sandblasts everything in its path. The dust sears flesh like bleach. Winds howl 160 kilometers an hour. Soon it will be impossible to breathe. There is nowhere to run. Nowhere to hide. An earthly dust storm can last for days. But a Martian storm lasts for weeks or months. Pascal Lee is the man who's tasked with equipping us to deal with it. A man who's most at home in the extreme environments of Earth. Like his base at Devon Island's Horton Crater, a polar desert in the high Arctic. A barren, freeze-dried Martian landscape formed by a meteorite impact 39 million years ago. Lee is on an expedition with a prototype spacesuit and a proof-of-concept Humvee, designed to test the limits of Mars exploration. But nothing NASA does is ever easy. When NASA astronauts make it to Mars, they'll face many problems. But this equipment test in the high Arctic has hit one that won't exist: water and mud.
We were trying to avoid making deep tracks on the trail by driving on the creek bed, but turns out the creek bed was pretty soggy. So we got stuck, and somehow there's no more traction on either of the tires. All four have lost traction here, and hopefully we'll make it back home for dinner. Let's try this. Any action? Nothing.
The Humvee is more than 3.5 tons of technology-packed metal and is challenging the team's pulling power.
You want to try this? No, huh? We're just going to dig a little trench and bury this deeper.
An incident like this on Mars could be the end of an expensive expedition.
That's what a winch is for. You sort of come prepared with the right gear. There are a number of options that you can consider. We usually try the lazy ones first, and then it looks like the hard way is inescapable.
But after 3 hours, they're up and running again.
So we don't have much room in this place. You got to keep everything well organized. These two doors will remain connected so that the dust that is on the back of your backpack or on the outside here of your wall will always remain confined and sealed inside, and so your interior environment will not become contaminated with Martian dust. You slide into your suit gently, legs first. Find a way to catch the boots. Slide your second sleeve. I'm going to close this double back door and go on EVA. See you later.
The kit has been evolved from biohazard suits. Lee has to test it for ease of use. This is the first time he's taken it out for a walk.
When you explore a hostile environment, what you try to do is be prepared. You always try to plan things. And so the enemy of expeditioning is the unpredictable. Dust storms are in that category. It's a fantastic weather phenomenon, and it's really important that we understand why they take place on Mars and how they come about. Not just for the sake of understanding Mars, but for the sake of understanding how such a thing might happen on the Earth if conditions changed. And so this is about a multi-planetary approach to understanding weather phenomena, not just focusing on the Earth, but looking at other worlds.
There we go. Snake your way out of this thing. You bend over backwards with the space program and to get out of the suit. No amount of engineering can fix a bad concept, so this is why we do all this work. And this EVA went really well. I'm only covered in sweat, no dust though.
A journey to Mars, in many ways, is sort of the mother of all camping trips. It's the mother of all exploring expeditions.
But it wouldn't take much to turn it into the vacation from hell. And scientists are not yet able to protect a Mars mission from the deadly threat of its dust. And if we're not ready to go to Mars, we're certainly not prepared for Mars to come to us. Our Martian dust storm is racing at almost 160 kilometers an hour. A wave of dust 40 kilometers high that hits like a freight train, consuming our world for weeks or months. The sun is obscured. Technology fails. Crops die. And so do millions of people. Survivors left to face disease and pandemics. But this is just the beginning. months of Martian storms leave meters of dust covering our world, changing our landscape. A monstrous Martian dust storm could return over and over again, growing to bury the Earth, spreading confusion and fear for our future. But from an unlikely and inhospitable place comes hope. In one of the driest deserts on Earth, there is an amazing story of survival. The core of the Atacama Desert of Chile is thought to be shockingly similar to the surface of Mars. Save for a blue sky, this looks just like the view from the Mars Spirit rover. This desert, with its giant boulders and smaller rocks, is over 10 million years old. Much of this landscape is made up of salt deposits and coarse sand, formed from volcanic rock over many millennia. The Atacama is a sandy wasteland, a virtual dead zone in its most arid regions.
There's absolutely no life around you. You can spend weeks and weeks roaming in the Atacama Desert and you will not see any green.
Scientists come to study the limits of life in a place where none has ever been found. There are stretches here where rain has never been recorded.
For us, for many scientists, the most important reason is to know the limit of life in our planet.
Jacek Virchow is a space chemist from Spain. He made his first visit to this desert in 2005, and on his first day, he took a walk, broke open a piece of halite rock, and made a shocking discovery.
Always in these extreme places we can find some forms of life.
He found a very curious deposits, which are basically halite deposits, salt deposits, and they were sitting right on the surface. And with his hammer, he went there and he cracked one of them open. And to his surprise, he saw that inside this halite, inside this salt, there was actually plenty of life.
The rock contained living cells, microbes thriving inside the salt rock. Virchow tested more and more rocks. They were all colonized by primitive, unicellular organisms. He had discovered a vast, unknown, hidden habitat.
In the Atacama Desert, most dry place in our planet, we have halite. This halite is colonized.
The porous halite had absorbed the tiny amount of water vapor from the air, moisture that was supporting life.
The fact that there is so much life in the halite and in the gypsum is telling us a fundamental thing about extreme dryness. It's telling us that life can adapt to these conditions. Microorganisms were the first ones to arrive, more than 3.5 billion years ago. And some of these microorganisms are still here. Everything you can throw at them, they've been able to survive it. And I think these little guys deserve a lot of respect. When you go to the Atacama, you see no life anywhere. You don't see trees, you don't see bushes or grass or anything. But then you take the halite and you put it under your microscope and suddenly you see like a rainforest.
Our deserts may compare to Mars, but the dust storms that roam them will never bury the Earth. The oceans of our small blue planet will not permit a dust storm on a Martian scale. Water that offers us protection and also gives us life. Life that will survive a storm against all odds. Ashes to ashes, earth to earth, dust to dust. For dust thou art, and unto dust shalt thou return, until it starts again. Imagine a day like any other. The forecast says cloudy with a chance of showers. And for once, the forecasters get it right.
Good morning, San Francisco. We have some very exciting events to talk about.
Except for one thing. The clouds are noxious. A downpour of liquid methane is only the beginning. Gigantic bolts of lightning. A flash freeze brings crystal silence. shattered only by winds of over 17,000 kilometers per hour. Don't bother bringing an umbrella. Parts of our world are global hotspots for extreme types of weather, like the windstorms and typhoons that cause billions of dollars of damage to property and leave, on average, over 12,000 people dead every year. But there are worlds in our universe that are consumed by weather on a much greater scale. Space storms. They may look vaguely familiar, but they're off the dial in size and power. And this weather gets wilder as we travel farther from Earth into the solar system. Jupiter has storms that rage for centuries. Saturn has lightning bolts 10,000 times more powerful than those on Earth. Storms on Uranus churn at hundreds of degrees below zero. And Neptune's winds howl at almost twice the speed of sound. This is a quest to unravel the mysteries of alien storms, wild and furious, raging on planets and moons throughout the solar system and beyond. But we can only understand the true power of these storms by seeing the destruction they would cause to a familiar earthly city. San Francisco is accustomed to unpredictable weather. It can be cool and misty in one location, and sunny and warm only a few kilometers away.
It's bizarre how when it's cloudy like that, you can't see anything, like, at all.
No, I know. Never ceases to amaze me.
Nothing can prepare the city for a fantasy storm from a distant moon.
How many teeth? Good, yeah?
Fantastic.
Okay.
First stop on this exploration of the solar system's weather is a moon of the planet Saturn called Titan. Titan is Earth's smaller, weirder kid brother. Temperatures as low as minus 180 degrees Celsius freeze water as hard as granite. Clouds of orange-yellow smog drizzle hydrocarbons into lakes of natural gas. Its volcanoes erupt with natural antifreeze. It's planet Earth reimagined as an environmentalist's worst nightmare. San Francisco gets its share of thick fog, but the one rolling in this time is a cold methane smog from Titan.
Good morning, San Francisco. It's a beautiful day in the Bay Area, and we have lots of exciting events to tell you about this week. Look at the color of those clouds.
No, I'm gonna roll on this.
Oh, Jesus!
On Titan, this weather has persisted for eons. Thick smog, thought to leave particles of sand-like grains on this moon's surface. Deposits that lead to a mystery. In 2005, the Cassini spacecraft orbiting Saturn captured puzzling images of Titan. Dark streaks were visible, cat scratches that turned out to be the biggest dunes ever found outside the Earth. They form a broad band around most of Titan's equator, soar 150 meters high, and cover an estimated 1/5 of the moon's surface. An alien desert landscape made from crystallized smog. The mystery is what forces shape the smog particles into high dunes. One thing is certain: where there are dunes, there must be wind. NASA scientists Rosalie Lopez and Steve Wall are Titan specialists. They're trying to solve the mystery of its dunes.
if we were on Titan right now, and it would be great to fly around Titan in a helicopter.
But since they can't go to Titan, they've come to the next best place, Namibia, southern Africa, the oldest desert on Earth, with dunes that are eerily similar to those on Saturn's biggest moon. Dunes that are sculpted by the wind.
Certainly got plenty of wind here today.
Oh yeah, and plenty of sand too. Just no methane.
Cassini's images of Titan's dunes provide hints of the angle of their slopes.
If we can get the same sort of thing here in Namibia and compare that to what we see on Titan, then we can get a sense of whether the faces of the dunes are carved in the same kinds of way by the wind on Titan as they are by the wind on Namibia.
Sand dunes cover just 2% of the Earth's surface and are nature's temples to the wind. Namibia has some of the biggest on the planet, dating back 5 million years, including longitudinal dunes. They stretch out in a line up to 80 kilometers long and soar up to 300 meters high. Incredibly, they have similar shapes and spacings to those on Titan.
Wow, look at the dirt action right over the ridge.
Oh yes, beautiful.
Dunes are like weather vanes. Their pinnacles are buffeted by the full power of the winds. But this dune is the height of a skyscraper, a 2-hour climb to the top. A rare opportunity for astronomers to get their hands dirty, and their feet.
Oh, it's getting tougher.
Careful.
I know, don't fall down the slip face. Oh, God.
Both sides are loose and unstable. This suggests that the winds shaping it are blowing from more than one direction.
Oh, God.
The winds are too complex and chaotic for Wall and Lopez to decode them through direct observation. So instead, they try to reproduce the dune's shape by taking control of the winds with leaf blowers.
We have this turntable. It's about 1.5 meters wide, and it's loaded with sand, a couple inches of sand. The turntable can then be rotated in one direction or another in order for us to simulate the wind changing.
This is going to be hard. Oh, perhaps not so hard.
It's easy for you to say.
This is fun, though. It's like playing in the sandbox again.
Absolutely. Absolutely. Sandbox for grown-ups.
By simulating wind from different directions, they can work out what combination produces a longitudinal dune.
See what we just wiped them out.
Yeah, but there is...
Oh, I missed it.
Yeah,
all right.
there's a transition.
Yes. Cool.
Linear dunes begin to emerge as if by magic. Their discovery indicates that the same forces may be at work on Titan.
On Titan, we find longitudinal dunes, very much like we have here in Namibia. Perhaps they are formed by winds in 2 directions, and these winds will sculpt these very long linear dunes.
If Wall and Lopez are right, Titan's dunes may have been formed by winds blowing in from alternating directions. These massive dunes, and another rare landscape, are products of Titan's unusual weather. At Titan's higher latitudes, the arid dunes give way to a wetter climate of mountains and lakes. Titan is the only other known celestial body with surface lakes. Recently, a huge storm was spotted at its south pole, producing a massive downpour of rain, a monsoon made of methane.
That doesn't look like normal rain.
Hell no.
Titan's weather is complex, like the Earth's. It has a methane cycle the way Earth has a water cycle. Lakes composed of a methane-ethane mixture as vast as Earth's largest lakes, complete with familiar-looking coastlines and islands, evaporate, forming noxious orange-yellow clouds in the atmosphere that return to the lakes as methane drizzle. Titan's frigid, flammable methane rain is falling on San Francisco. The raindrops are the size of hazelnuts. On Titan, they fall in slow motion, thanks to the planet's thick atmosphere and low gravity.
Now, San Francisco has seen its share of strange sights, but I'm standing in the middle of the most bizarre storm this city has ever seen. Some people look surprised, some are frightened. You know, everyone's asking, what's next? It's as if some kind of alien.
What happened?
Oh, it stopped. There goes our story.
The torrential downpour of rain from Titan leaves San Francisco soaked in methane. Just don't light a match. Titan's weather may be weird and wild, but it's dwarfed by the huge storms raging elsewhere out in the cosmos. The planets known as gas giants, Saturn, Jupiter, Uranus, Neptune, have the wildest weather in the solar system. Jupiter is the biggest planet of all. One of its storms, called the Great Red Spot, is twice the size of the Earth and has been churning for over 300 years. The spot turns at over 500 kilometers per hour, twice the speed of a Category 5 hurricane. Enough power to devastate San Francisco. The power of the Great Red Spot is enormous. But scientists still don't know where all that energy comes from. It's one of the biggest mysteries in planetary science, how storms like the Great Red Spot actually work.
The question is, you know, why do they last so long? Because all around the outside of these storms is turbulence, chaos, churning, you know, what you would imagine would tear apart any kind of a structure.
Scientist Tim Dowling's life work is to reveal the dynamics of these giant storms, the different forces at work within them. But there's a problem. Cloud cover prevents him from looking into the heart of the storms.
So I have a very good idea of the top dome, but I don't know what to put on the bottom. I need probes. We've only had one probe go into Jupiter. It's extremely expensive to do that.
It's not only expensive, Jupiter's huge atmospheric pressure quickly crushes probes. So Dowling looks to the Earth as his laboratory for alien storms. But he can't use our weather in his experiments because it's so different from the gas giants.
If you look at Jupiter, you see hundreds of storms, and they circulate sort of majestically and slowly. They just sort of spin and spin and spin. That just doesn't happen in Earth's atmosphere.
But there is one place on planet Earth where huge storms churn for years on end, just like the ones on Jupiter. Storms that until quite recently were hidden in plain sight beneath the surface of the oceans.
One of the most exciting analogs today is the ocean eddies. They have all the mathematical similarities of the storms we see on Jupiter, and they last up to as many as 8 years.
And to investigate them, he has found unusual collaborators. Elephant seals. Researchers at the University of California at Santa Cruz are trying to learn more about the feeding patterns of elephant seals and sea lions in the Pacific Ocean. But Dowling wants them to investigate storms on another planet.
The whole point of today is to put these devices out.
And this will stay on the animal for a whole year.
Yeah, it'll. If we don't recover it, it'll fall off this time next year when the animal molts.
Marine biologist Dan Costa puts satellite recorders on marine mammals to study their feeding patterns in giant eddies. These little understood phenomena are giant rings of water up to 200 kilometers across. They slowly turn for years under the ocean's surface. They are the hurricanes of the submarine world, the longest-lasting weather systems on Earth. But they are also rich in fish, prime feeding grounds for marine mammals.
Elephant seals travel all the way to Alaska, swim for 3 weeks, and get into where these eddies are forming, just like the eddies you see on Jupiter, but under the sea, and they go right into the middle and right down the core of the eddy. It's exactly what you want a probe of Jupiter to do.
The instruments attached to the seals record the density, pressure, temperature, and depth of the eddies. Information that Dowling can use to create a scientific model of the storms of Jupiter.
All right, well, let me show you Jupiter. Is a shot, the equator in the middle, this great red spot. Do you ever have any of them that actually merge? That's what I was wondering. You actually see them actually touch, because they always
that
merge.
looks just like the eddies we have.
Yeah, this is just like it. Yeah. We have this incredible opportunity to actually use that to improve our models of Jupiter. And once we have these models, that will really fine-tune what it is we don't know.
But first, you have to catch your aquanaut. Step 1, immobilize the target.
Doing anesthesia with seals is not like a dog or a cat because breathing is a very conscious effort in these guys. So the breathing process is under much more higher control. And if you anesthetize the animal too much, where they're completely unconscious, they can stop breathing. And that's not a good thing.
They begin the tag by taking hair and blood samples. But then, the seal's breathing grows weak.
She's not breathing as frequently as we like.
Suddenly, they have an emergency on their hands. They move quickly to kickstart her breathing with a shot of stimulants.
3 cc's in the tongue.
She doesn't respond right away. Dowling may lose his leading aquanaut before her mission. Costa has one last chance to revive her.
That stimulate the breathing?
That's the idea. Is that a breath? What was that? Okay, there we go.
The elephant seal finally resumes breathing.
Okay, let's go ahead and put the stuff on her.
In what may be a first, a planetary scientist helps a marine biologist affix a radio transmitter to an elephant seal's head with hardware store glue, in the hopes of finding out more about a storm on the planet Jupiter. In a few days' time, the tagged female will return to the sea with the rest of the herd.
Here they come. There was a million of them. How many are there?
There's about 20 of them. 20 or 25.
Oh, how cool is that? So how fast is time going here?
This whole thing is about 9 months.
As they forage for food in the eddies, their every move will show up as animated worms on Dan Costa's laptop.
You know, here you are, your seals are just going right in and out of where we need to be.
Yeah, well, our elephant seals will give us a nice temperature profile, and some of the animals with the salinity tags will give us a cross-section of the temperature salinity, so we'll be able to get density.
That's awesome.
Dowling and his colleagues have made a remarkable discovery. The proportions of these underwater hurricanes are uncannily similar to those on Jupiter. With the data from his aquanauts, Dowling will be able to calculate the dimensions of alien storms and unlock the secret of their power, realizing his greatest dream. Actually, his second greatest dream.
If only I could borrow one of those elephant seals and bring it to Jupiter. It would be great.
Moving away from Jupiter, further out in the solar system, the next planet encountered is Saturn. Like Jupiter, it is home to gigantic storms. But the Cassini spacecraft has recently discovered it has something else. Lightning.
God, what the hell was that?
Saturn has the biggest known thunderstorms in the solar system.
Yeah, let's get some of this.
To understand their scale, imagine what would happen if one of them lit up San Francisco.
Now my teeth. Good. I'm standing in downtown San Francisco under the most amazing cloud cover. Oh no, the wind is starting again. Damn it!
Saturn's storms can rage for months at a time, over an area 3,000 kilometers across. Lightning flashes are 10,000 times stronger than those on Earth. The sound of the thunder is like standing next to an explosion of a ton of TNT.
You know what? I gotta see this. Yeah, I got it. I gotta go. Come on.
Moving farther out, Uranus is too far from the Sun to be warmed by its rays. It is the coldest planet in the solar system, with temperatures of over 200 degrees below 0 Celsius, cold enough to flash freeze Earth. The silence that descended on San Francisco is about to be broken by the most powerful winds in the solar system. The winds of Neptune roar in at 2,000 kilometers an hour, shattering the frozen silence of the city. In reality, storms like those on the gas giants never develop on Earth. To find out why, Tim Dowling has come to Woods Hole Oceanographic Institution.
This is great. It's been a while. Yeah, it sure has.
For decades, oceanographer Jack Whitehead has been using dye in tanks of water to study the movements of the world's oceans. Now, Dowling has asked him to replicate Earth's tempests in a scientific teapot.
This is just like the train of cyclones and anticyclones that you would get in the mid-latitudes across the globe.
Yeah. You know, I was a little skeptical of this whole idea of doing the small tank, and I'm glad we did it.
There's only room for approximately 6 major storm systems on Earth at any given time. As Dowling looks on, Woods Hole's tanks reveal the crucial difference between Earth and the gas giants.
You know, this guy here has all the room he needs. He's basically evolving in its purest state right now, just like on Neptune.
Storms on the gas giants are free to spin and drift across vast distances. But Earth is so tiny, that even our much smaller storms bump up against each other. On August the 7th, 2006, a NASA satellite captured this extraordinary image of 3 new storms spinning over the western Pacific Ocean, where hurricanes are called typhoons. The strongest of these triplets, Typhoon Saumai, was born just 3 days before as a tropical depression. While it was growing into a storm, another tropical depression formed some 1,500 kilometers to the north. By August the 6th, it built into Tropical Storm Maria. Just as Maria reached storm status, the sea gave birth to a third tropical storm, Bhopal. 3 huge storms crammed into a small compass of ocean.
It's all about elbow room, and Earth just simply doesn't have very much. Imagine you're watching a beautiful ballet, where the ballerinas are arrayed across the stage, pirouetting just elegantly in a wonderful pattern. Take those same ballerinas, maybe 6 of them, and put them in a large elevator, ask them to dance the same Swan Lake, and what do you get? You get elbows flying, you get tempers flaring, you get chaos. The elevator, where the conditions are cramped, is Earth's atmosphere.
Despite being born in the same place around the same time, only Saumai would become a Category 5 super typhoon. Maria grew into a small typhoon. Bhopal never grew bigger than the tropical storm. Each of the triplets sucked their energy from the heat of the Pacific Ocean. As they grew, each went their separate way and hit land in different places, hundreds of kilometers apart. When big storms reach land, cut off from the sea, their source of life, they start to die. But at the time of their birth, no one could predict their futures. Earth's weather is more complex than that of any other known planet because of our small size and our combination of mountains, water, and abundant sunlight. And that complexity makes our weather hard to predict.
We're all inhabitants of Earth's atmosphere. We're all used to weather, and you kind of get the sense that weather is unpredictable. When you start to compare Earth's atmosphere to the storms you see on Jupiter and Saturn and Uranus and Neptune, we start to understand that Earth is actually anomalous.
And it's that anomaly that makes Earth's weather special. Our biggest storms can blow up, wreak havoc, and disappear in just a few days. An extraordinary feature in our solar system, and one that makes Earth a storm world.
And I think the consensus from the solar system exploration of the last 4 decades is, in fact, we live on the most unpredictable planet.
When a superstorm strikes, this unique lack of predictability results in many more deaths. So scientists need to better predict their frequency. Campbell Leo is closing in on a killer. He's a paleotempestologist, a weather scientist who tracks down ancient storms. Today, he's focusing on records dating back 1,000 years. Leo is searching the past for evidence of centuries-long periods in which huge superstorms were much more frequent.
If we know the history of typhoon in this area going back to hundreds of years, including some very strong typhoons that we have not seen in our lifetime, then it would give us a better idea of what the worst case scenario is. And it can help us to better understand the risk faced by the people living in this area.
Research suggests that we've entered another era of superstorms. Scientists have discovered dramatic accounts detailing some of the most destructive storms in recorded history.
弘治2年6月初7日夜，永嘉季风甲乙自东北来生，如陆雷摧屋折木，河道损石之势，平阳野然。
Typhoons wreaked havoc on this coastal city centuries ago.
In the second year of Emperor Longqing, this is approximately 1568 AD. In the county of Yongzhou, which is Wanzhou today, there was a very powerful wind and rain. It killed more than 30,000 people, and it flooded the city for 3 days. It also said that 50,000 houses were destroyed, and 400,000 households suffered losses in this event. This is one of the deadliest typhoon events recorded in Chinese history.
The archive reveals that over a 300-year period, from the 13th to the 16th century, the typhoons hitting Wanzhou caused massive damage and killed tens of thousands of people. Liu is on track to prove the existence of earthly cycles of intense storms. But he also seeks physical evidence of these past monsters, and they leave their tracks in the dirt.
China as a country is affected by strong typhoons many times a year. So for China, this is really an important natural hazard that people have to deal with.
Wanzhou is a prosperous historical port in an isolated mountainous region of China. Typhoons here are common in late summer, and a lengthy cycle of extreme typhoons would be disastrous for the city's 8 million people. For Liu, it's a race against time to gather the evidence needed for prediction. Typhoon Saomai made landfall here in August 2006. It was the most powerful storm to strike China in over 50 years. Saomai killed more than 400 people, destroyed 54,000 homes, and displaced 1.6 million residents. The storm lasted 6 days, but she left her fingerprints all over this coastline.
What we're seeing here is a layer of sand with shell fragments overlying a layer of mud in the bottom.
Superstorms like Saomai cause massive ocean surges that lift sand and shells from the sea floor and dump them elsewhere. Liu is digging in a muddy lagoon between two sandbars, searching for the telltale layer within the mud.
And the sand layer at the top with the shell fragments that indicates a storm deposit that was probably laid down by a recent typhoon affecting Wanzhou. And the most recent typhoon is Saomai in 2006.
Liu now knows what a superstorm deposit looks like, a benchmark for ancient storms. He and his team drilled down into the past looking for prehistoric deposits. The same fingerprint could build a picture of the Earth's storm cycles. It's the first time this work has been done in China.
This is forensic work. Instead of trying to solve crimes, we are looking at the scene, maybe a crime scene that was left by an ancient storm.
This 6-meter-long core sample represents approximately 1,700 years of history.
It's a good one. It is a good one. The good thing about it is that the bottom here, there is sand.
Big stone layer,
Looks
maybe.
like, looks like that there is a layer here with shells. So that might be the exciting part.
Yeah. Very nice.
All right. Wow, this is wonderful. This is wonderful.
At least this one should be stone layer.
This is a clear storm layer.
Yeah.
Incredibly, Liu and his team have found an ancient storm, a caged dragon. Its boundaries clearly defined by a distinct layer of deposits in the mud.
And also with some shell debris as well. You can see even the whole shell here.
Yeah.
That's exactly what we are looking for, and looks like that we've got the fingerprint of a prehistoric storm.
Liao now has a time capsule, evidence of huge storm cycles lasting hundreds of years and stretching back millennia. His work awards Earth a place amongst the storm worlds of the universe. Worlds like Neptune, where 2,000 kilometers an hour winds make Earth's worst tornado feel like a gentle breeze. Deep freeze Uranus, with icy blasts that will never freeze our warm planet. Saturn, whose gigantic thunderbolts shrink earthly lightning to mere sparks. And Jupiter, where storms howl for centuries, while Earth's worst tempests often last no more than a week. Meteorologists struggle to accurately foretell Earth's weather even days in advance. But the most hellish weather in the known universe happens with clockwork-like predictability on a distant world. 200 light-years away, on a planet orbiting an alien sun, the most powerful storm ever detected by human beings is raging. On an autumn evening, a network of astronomers across the United States are preparing to observe a hyperstorm in real time. Leading the campaign just outside of Boston is an astronomer from MIT, Josh Wynn.
The event that we're observing tonight actually took place almost 200 years ago because this star is almost 200 light years from the Earth.
It's a storm that broke when Napoleon was trying to conquer Europe. And it's playing out on a planet with a phone number for a name. HD 80606b has an extremely close encounter with its star every 111 days, unleashing the worst known weather in the universe, a gigantic atmospheric shockwave that convulses the planet. We can observe this event because after this close approach, the planet crosses directly between its sun and the Earth. This event, called a transit, is similar to an eclipse. During the storm, the planet's entire atmosphere rapidly heats up 700 degrees Celsius, becoming hotter than volcanic lava, generating shockwave winds that howl at 18,000 kilometers per hour, almost 5 times the average speed of a rifle bullet.
If a storm like this were to somehow be generated on the surface of the Earth, then it would be unmitigated bad news. The combination of the wind speed and the extreme temperatures would basically vaporize any structures.
The astronomers hope to track a shockwave storm in real time during a transit.
Well, the star won't be visible for us for as long as 3 hours, so hopefully somebody else, Don or Melanie or the gang in Florida, will be able to pick up where we leave off. Otherwise, we might...
The transit lasts for 12 hours, but is visible from any one location for only 3 hours before our sun rises and the heavens can no longer be seen. So a chain of observatories across America are working in relay to observe the entire event.
It's only observable for a few hours before the sun comes up and spoils the observations. So that's why we've organized a campaign involving observers across the United States, so that in each time zone, the observer will have a couple of hours to acquire images of the star and to measure its brightness before passing off to the next time zone to the west, and so on.
Any error in the timing between observatories or clouds obscuring the star from view, and the campaign may miss crucial parts of the eclipse.
Don, are things still as bad as ever in Indiana?
Well, the skies are clearing a little bit.
Fantastic.
Get better, I'll go to the surgery out.
And Phil, how do things look in California?
So hopefully it'll hold up. We'll be on in about 3 hours and change.
Okay. And Gil, it sounds like things are going really well in Arizona.
We're in great shape. It's clear, the seeing is a little bit soft, but everything's going really well.
Astronomer Gil Esquerdo is at the Whipple Observatory near Amado, Arizona.
It's very rare to find a campaign put together like this where you've got multiple observatories working on the same object, the same target. They happen, they're not unheard of, but they're very rare.
The shockwave planet was discovered in 2001. It's a gas giant, a little bigger than Jupiter. It circles a star in the Big Dipper constellation, but its orbit is eccentric because there is another star close by whose gravity affects it. Astronomer Greg Laughlin is the leading authority on the shockwave planet.
This planet is particularly interesting because it has the most eccentric orbit of any planet that's been discovered anywhere.
The planet tears through its close encounter with its star in less than a day.
It's a very strange planet. That's what makes it interesting.
Melanie Good is a graduate student in astronomy at Pittsburgh University. She's at the university's observatory. She'll be one of the first people to see the star, along with the Wallace Observatory and the Rosemary Hill Observatory in Florida, where a group of students and scientists and an amateur videographer
Lunar project
are looking forward to staying up all night, staring at a couple of stars.
So this is a computer. They're staring intently at it.
The astronomers want to measure how much the star's light dims when the planet crosses in front of it.
By measuring how much light is blocked and also the duration of this miniature eclipse, we can learn a lot about the size of the star and the planet and the characteristics of the orbit.
Planetary scientists need this information to reconstruct the story of the biggest known storm in the universe.
They're in the middle now. We have them. It's really exciting. Already 2 stars like this. Right on. Like a rabbit in the headlights. We're not going to do stuff with them for hours. Late at night.
We're able to observe the star here at Wallace Observatory, and we're closing in on the time of first contact.
So this is what the guys are seeing right now through their telescopes. They just see the pair of stars just sitting there calmly against the black of the night sky. And so it's a very subtle scene from the Earth, and it's very hard to imagine that anything's happening there. But in reality, there's actually a tremendous storm in progress on the planet.
The star dims as the planet crosses in front of it. The side of the planet facing the star is now absorbing almost 100 times more heat than when the planet is at its farthest point from its star during orbit. This is when the storm is reaching its peak. While this extraordinary drama plays out on HD 80606b, the weather around Boston is changing too. Clouds are rolling in, obscuring the observatory's view of the transit.
It is raining, so we need to cover the telescopes as soon as we can.
Bad weather on Earth may destroy this opportunity to witness the worst known weather in the universe. The Wallace Observatory gets shut down by rain. But other observatories across the United States may be having better luck observing the transit.
Gil, how much longer before your telescope in Arizona can pick it up?
I'm ready to go as soon as it'll let me, and then we'll be good all the way through astronomical twilight and all the way into nautical.
Excellent.
Elsewhere, observatories in Pennsylvania, Florida, and Indiana managed to gather the last of their data just before dawn. As the transit moves west, both Texas and California are rained out, leaving only the Whipple Observatory in Arizona.
And now, we are running. We're on Sky and we are taking real data. Thank goodness. Knock on wood or particle board or whatever. I'm kind of excited about this all of a sudden. I don't know why. What you're doing, you're one link in a chain. And so it's nice to know that we haven't broken the chain. You know, we've got sort of a weak spot in the middle, but we've managed to fill it in as best we could.
Whipple carries on for the next 3 hours until the sky starts to brighten before dawn in Arizona.
Gil, were you able to start with no problems from Arizona as well?
I most certainly was. I was able to get on just when I thought I was going to. The seeing is improved, which is a very good thing. Our star images are much more stable than they were earlier in the night.
So this is really great. It means that we've been able to get complete coverage of the eclipse.
A rare collaboration of observatories has tracked the biggest known storm minute by minute.
All right, guys, well, we had a really successful night. Thanks again for all your efforts. We got exactly what we needed.
It's the dawn of a new day, and the sun begins to gently warm the western hemisphere. On planet HD 80606b, the intense heat of its star causes its atmosphere to rapidly expand, like a nuclear explosion, unleashing a giant shockwave, blasting over the planet at 17 times the speed of sound on Earth.
If you're actually on the night side of this planet, before you were able to hear anything, you would see that the sky was suddenly starting to glow. So the weather front that is arising as a result of this huge burst of heating, it comes careening around onto the night side of the planet. And then all of a sudden, in a blink of an eye, the shock wave, which is traveling faster than the speed of sound, would sweep over you. The temperature would go up by hundreds of degrees in a matter of seconds, and you would hear this tremendous low-frequency noise because the atmosphere is in a tremendous state of agitation. .000-mile-per-hour wind speeds would be enough to pretty much devastate any buildings. And anything that contains carbon in it would be completely vaporized. And so it would be absolute, complete devastation.
Alien storms in our universe are huge, but easy to predict. The shockwave storm has exploded like clockwork every 111 days for millions upon millions of years, and will do so for eons to come. Monster storms on the gas giants howl on and on with nothing to stop them. But our small planet's rare combination of mountains, water, and abundant sunlight makes its weather the most complicated and the hardest to predict in the solar system. It also protects us from the enormous storms now raging across the vast reaches of the cosmos. So the next time you complain about the forecast,
Good morning, San Francisco.
be grateful. An alien force stalks the Earth with the power to cripple civilization.
A solar flare was released from the sun yesterday, was accompanied by a second and potentially more serious event known as a coronal mass ejection.
A giant storm explodes on the sun with the power of 1 billion hydrogen bombs.
Scientists believe that it may impact Earth. The public is being asked to stay on alert.
A solar bomb that will paralyze modern technology and send us back to the steam age. We know that a storm like this can happen. It's happened before. In the power center of the United States of America, a star chamber of top scientists and policymakers meets to discuss the sun, they're sharing new research about an event that could destroy technology on Earth and threaten the lives of millions. A storm from the sun that can erupt when solar activity peaks.
We're just getting to the point that we are now understanding that space weather may be, in fact, the largest natural disaster that could occur.
The scientists are speculating on what could happen if a massive solar storm came down to Earth.
Your internet goes out, your cell phone goes out, your light goes out, and you go, oh my God.
And they've a platform to build from because it's happened before. On September the 1st, 1859, English astronomer Richard Carrington recorded an astonishing event. Astronomer and historian Stuart Clark has spent years analyzing Carrington's findings.
Every clear day, he comes into his observatory and sets up his telescope, and then spends hours sketching what he sees in the most precise detail. He then spends hours calculating. In the 19th century, that's what he has to do if he's going to make any discoveries. Carrington is obsessed with the sunspots, and he believes if he can understand them, he can understand what's happening inside the sun. That compulsion is about to pay off.
Sunspots are dark patches on the sun's surface indicating areas of intense magnetic activity. But in 1859, Carrington knew them only as mysterious patterns that constantly changed. And as he watched them on September the 1st, they were bulging to 10 times the size of the Earth. Then, without warning, two intensely bright beams of light appear above the sunspots. Blasts like colossal nuclear explosions that lasted for 5 minutes before vanishing from Carrington's view.
Whatever's happening on the sun, the power behind it is tremendous.
As quickly as they appeared, so they disappeared. And that's when it hit him. Who on Earth was going to believe this? The blasts were coming from the sun's fiery halo, its corona, the sun's superheated atmosphere. A place where gases sizzle at 2 million degrees Celsius. A place so hot that atoms are ripped apart, sending plasma blasting out across the solar system in a steady shower of particles called solar winds. And sometimes the sun's corona erupts with a colossal burst of energy, a coronal mass ejection, spewing up billions of tons of blistering plasma from its surface. A fiery expulsion that whips the solar wind into a hurricane-like frenzy, creating danger to life on Earth. That's what Carrington saw. Contemporary scientists have spent decades studying space weather, the name given to radiation from the sun and other stars. But they did not realize the threat a sunstorm posed until recently. Until we better understand the sun, we won't be able to protect ourselves from its fire. But ironically, one of the best times to study it is when it's hidden from our view, in a solar eclipse. Professor Jay Pasikoff is an eclipse expert.
I'm going to take a look at sunrise, see if I can see anything in the east.
He and his team chase this cosmic phenomenon all over the globe. And the thing he really needs is a clear sky.
Well, I see structure in the clouds. That's better than solid clouds. We will see.
Pasikoff of Williams College, Massachusetts, has brought his team to China, where he believes he has the best chance to monitor the longest total eclipse of the 21st century.
This will be my 28th total solar eclipse out of my 49th eclipse altogether.
A total solar eclipse is when the moon passes directly in front of the sun, dimming its brilliance. At totality, the sun's outer atmosphere is clearly visible. The corona, a halo of fire outlining the moon.
Eclipses are very rare opportunities to study certain parts of the sun. If you were a heart surgeon and I said, you've got to go to Africa to get a look at the inside of a heart for 3 minutes or 5 minutes, and then you have to wait a year and a half to do it again, you'd go.
A total eclipse is the perfect opportunity for Pasikoff to spot clues about how the sun really works. And this one offers one of the best chances in his lifetime.
We only have a few minutes to study this part of the sun, and every time we learn something more, and it all adds up to improving our understanding.
The mystery Pasikoff wants to solve is why the sun's corona sizzles at 2 million degrees Celsius when the sun itself is burning at only 6,000.
But when I look up at the sun now, I see the everyday surface of the sun. You know that if you have a hot stove and you're too hot and you walk away, it gets cooler. Whereas on the everyday sun, if you walk away or you move away, it gets hotter. And that's what we're investigating.
It defies common sense, as if the air in the kitchen were hotter than the stove. So what is causing the corona to superheat? The answer to this mystery affects us all.
It's critically important to understand what's going on in the corona, because that's the reservoir of gas from which these huge coronal mass ejections are erupted.
Astronomer Stuart Clark is also in China for the eclipse. But he's with the masses on the banks of a river in the lowlands.
At the moment of totality, you get a few minutes of seeing the outer atmosphere of the sun. So this is your time to try and take a peek at something you can't naturally see at any other time. And in those moments, you never know whether you will be the one that sees the clue to make it all make sense.
At 6 minutes and 39 seconds, today's eclipse will be the longest totality for 100 years. A chance to solve one of the biggest mysteries of science. Pasikoff's team is focused on the atmosphere just above the solar surface, ready to pounce on telltale signs of colossal heat pumping into the corona.
That million-degree gas may oscillate a little bit in brightness. We're interpreting that as a sign of how the corona gets to be very hot. I can see the full sun now. Okay. No sunspots, of course. Well, here's a little cloud in front of the sun, but I'm seeing the whole distance. 15 seconds to first contact.
First contact. The moon starts to nibble the sun. One thing stands between Pasikoff and understanding the sun's corona. That's weather on the Earth.
Not looking too encouraging at this very moment.
Thick cloud cover threatens disaster. Until scientists decipher the inner workings of the corona, it's impossible to predict when the next big Carrington event will occur. And Clark can only imagine the havoc it would wreak on our technological world. Clark sets his disaster scenario at the scene of an eclipse.
At the moment that the moon covers the sun, so we see the ghostly outer atmosphere of the sun, the corona. And for much of astronomical history, the eclipses were the only time you could ever see this. And this mysterious outer atmosphere continues to defy our understanding even today.
We're about 60 seconds to totality.
I'm gonna call my dad. That's good. I really wanted him to be here, but he had to work. Dad, no, I'm standing right here. Yeah, you should be here. Okay, I'm gonna send a picture to you. Hold on. Okay, I sent it.
Hey guys, come take a look at this.
Jason's photo of the eclipse.
Wow, that's nice. Wow, that's cool. Oh, look at the background there.
Yeah.
If the flare took place directly aimed at the Earth during an eclipse, you wouldn't see it directly because the moon is in your way and blocking it. The first you would know is as the moon moved away and you saw this gigantic halo of boiling gas coming towards you.
Did you see this?
We're getting massive readings coming through. Massive readings. We just had a major spike.
On satellite?
1 billion tons of gas can just be thrown off, and that lumbers through space behind the flare and can arrive anything between 18 and 36 hours later.
Dad? Hello? Hello? Is your cell phone working?
No, it's like dead.
No, I don't have any service.
At the moment that the flare goes off, they can start calculating the power of the flare itself. It's likely to be something like a billion times the energy released from an atomic bomb.
We're reporting a CME at 13:08 hours. Confirmed? Yep. We had already registered a massive radiation spike on the GOES satellite. This looks big. Very big.
When you've got one of these coronal mass ejections coming at you, the clock is ticking every second.
There have been 5 major coronal mass ejections in the past 150 years, and no power on Earth could shield our planet against one like Carrington witnessed. 15 minutes may be all the warning we get. This is the Space Weather Prediction Center in Boulder, Colorado. It's the souped-up weather station that can spot sudden spikes in solar radiation. The people who work here monitor the sun 24/7 to give us as much warning as possible of impending disaster.
No space weather storms were observed for the past 24 hours. No space weather storms are expected for the next 24 hours.
Sudden increases in solar radiation can affect satellites and electrical grids, and endanger astronauts as well as aircrew and passengers. The SWPC forecasts space weather so that vulnerable technology and people can be better protected against its effects. If an 1859-sized storm blasts the planet, this will likely be the first place on Earth to see it coming.
If a solar flare goes off, the activities in this room would immediately become sharply focused in assessing the size, or what we think to be the behavior of the flare. Is it still increasing, or has it reached its maximum? But what you would see in here is a frenzy to try to understand as best you can what's going on, and then getting the word out to people that need to know. Questions are, has a coronal mass ejection occurred as a part of this eruption? And if one has, we'll be able to see the white material, the reflection of the sunlight off the electrons in this image to tell the forecaster that, yes, part of the solar atmosphere has been blown away. And now it's a ballistic problem. Where is it going? Are we in the path or not? For forecasters, that's the white knuckle time.
Yeah, take care.
Court Williamson is the center's operational specialist. He's been predicting space weather for over 10 years.
When is your next launch on a shuttle?
A CME makes all of us nervous. You know, that's the reason you put on a tin hat. I don't think we're prepared psychologically. I don't think we're prepared culturally. And I don't think we're prepared technologically for an extreme solar event.
Sometimes you need the bad thing to happen to wake people up, to make them realize that they have to pay better attention to it.
It's not if, but when.
The Earth's watchdogs are 5 satellites that monitor the cosmos for coronal mass ejections. The first detects the telltale blast of X-rays from a solar explosion in the sun. Then a pair of satellites called Stereo captures the CME in 3 dimensions, a chilling snapshot of monstrous size, shape, and speed. The next looks for the halo of light that says a CME is coming straight at us. Earth's last guardian is the ACE satellite. It risks destruction in the hail of particles to calculate if, when, and how hard the CME will hit. By then, it may be 15 minutes or less until impact. In 1859, the first warning signs of disaster meant it was already too late. 18 hours after Carrington witnessed the sun's flares, the skies were filled with an angry beauty, the northern lights, aurora borealis. Evidence that the Earth's magnetic field was battling radiation pouring down on us from the sun.
If you live in Canada, or Norway or Russia, the chances are you've seen the northern lights, but not like this. This is something far more intense. From the north, the lights are marching downwards towards the equator. Boston, Florida, Jamaica, Cuba.
All over the night side of the planet, people watch in horror as the skies turn deep shades of green and violet, then a spectacular angry red.
At the same time, from the south, they're springing upwards. In the Pacific, sailors see the most terrifying display in the sky. People think the world is coming to an end.
The Earth is in the grip of an all-powerful aurora, twisting the planet's magnetic field. All over the globe, compass needles are going haywire.
Something's pulling the Earth's magnetic field in all directions.
News of the strange event is spread by the 19th century's forerunner of the internet, the telegraph.
For the first time in history, we're developing a global network of telegraph lines carrying signals across North America and Europe.
It's a vast grid of electrical communications, the beginning of a new technological society. The perfect hunting ground for an alien force.
The Boston telegraph operator discovers that if he disconnects the wires from the battery, he can still send signals, powered only by the phantom electricity from the aurora.
The sudden massive surge of current shocks a telegraph operator in Philadelphia and starts fires in telegraph stations all over America. The sun pulled the trigger, raining missiles on Earth at more than 8 million kilometers per hour. In 1859, the telegraph was the only technology vulnerable to solar storms. In 1989, a solar storm 1/5 the size of the Carrington event shut down the entire electrical service for Quebec, Canada. 6 million people lost power in 92 seconds. We depend on technology, and our lifeblood is electrical power.
We're interrupting this program to bring you a special news alert. We've been told that this is a nationwide news alert directed by the White House in consultation with Homeland Security. According to NASA satellite images and data, a solar flare, which was released from the sun yesterday and which was responsible for widespread disruptions to wireless technology, from cell phones to GPS,
hey guys,
was accompanied by a second and potentially more serious event known as a coronal mass ejection, an expulsion of billions of tons of plasma from the surface of the sun. Scientists believe that it may impact Earth, and the public is being asked to stay on alert. We will continue to provide updates throughout the evening.
The solar storm that Stuart Clark imagined erupting during an eclipse is getting closer to Earth. The eclipse may be over, but the danger is just beginning.
The Earth's magnetic field is like a natural shield, and with the normal wind of particles that comes from the sun, it's more than capable of deflecting those. One of these CMEs, however, is generating its own much more powerful magnetic field, and the Earth can't win against that.
Geomagnetic storm is imminent. We have a national emergency condition red. Condition red.
This presents an unprecedented threat to our power grids, and the public is being warned to expect severe communication disruptions and electricity disruptions.
Can you turn that up?
It is not known at this time how widespread the damage will be, or how extensive or how long it will take normal services to resume. People are being asked to stay calm.
An event like 1859 could plunge large parts of the planet into darkness for up to 10 years. But to properly quantify the effects, it would help to know exactly how big the Carrington event was. In the intense dry heat of the desert, a block of frozen water may hold the answers. This is the Desert Research Institute outside of Reno, Nevada. And these two scientists believe telltale fragments of the 1859 solar storm are held here in suspended animation. Fire locked in ice. Hydrologist Joe McConnell has a freezer full of centuries-old ice cores, cut from deep in the frozen wastes of Greenland.
The beauty of an ice core is that it actually records the chemistry of the atmosphere, and so that can tell us all kinds of things.
Bruce Turatani is a space weather scientist from NASA's Jet Propulsion Laboratory. He hopes to find nitrates from the 1859 solar storm trapped in McConnell's ice.
Ice cores can help us go back hundreds of years. This opens up a whole new field of research for us.
When high-energy particles rain down on the Earth's atmosphere, they smash the air molecules apart. These recombine to form new molecules called nitrates. The nitrates dissolve in snowflakes and fall to Earth on the polar ice cap. Every snowfall adds another layer of ice. Then scientists can extract the ice for analysis in the form of deep cylinders called ice cores. In the ice core, any deep layer will have been covered by many years of snowfall. The deeper the layer, the older the year. This is a section of ice core that spans the years 1856 to 1861. It should contain the evidence of the Carrington event. And now the years melt away, releasing the chemical secrets of a 19th century time capsule. Meltwater that's ready for chemical analysis.
We're shooting up here. This is 1856, and this should, I think, this will be the winter of 1857. Okay. So January 1857. So let's see.
The all-important nitrate traces are in red and blue. If they can find nitrates in 1859, then Turatani could have hard evidence of the Carrington event.
This lab is absolutely fantastic. They can do things nobody else in the world can do. We're melting the ice, we're seeing what's in the ice, telling us about solar flares that happened 150 years ago. That's amazing.
It's not easy to find a solar storm, but a promising spike appears in red. However, forest fires can also create nitrates, so they must check for soot or black carbon.
Yeah, if we move over to the black carbon, we can see quite a large event corresponding to that nitrate. So I think it's a safe bet to say that that nitrate is primarily associated with burning.
It's a false lead. The spike is just evidence of a big forest fire from 1857. While Turutani tries to prove that particles from the sun are locked in 19th century ice, another scientist is scouring the clouds. Joe Dwyer is a professor of physics and space sciences. He's looking for particles from faraway suns that started their journey to Earth 10 million years in the past. Space weather that he believes is the trigger for an event that occurs 4 million times a day. Its name is lightning. We get energy from our sun, but energy from suns in other solar systems may be causing our lightning. Since Carrington's solar storm in 1859, lightning has killed many thousands of people. It's a massive discharge of electricity from the clouds. Thunderbolts that Joe Dwyer believes are sparked by cosmic rays from far distant suns.
Behind me is a research telescope that's designed to study the mysteries of the universe. Well, there's a mystery that's much closer to home. Lightning has currents of 300,000 amps, voltages of 100 million amps. Its temperature is 5 times the surface temperature of the sun, yet we still don't know how it works. Thunderstorms produce very large electric fields. It's like stretching a rubber band really tight, and it's waiting for something to go, and you need just something to let that rubber band loose.
Dwyer is a lightning expert. He thinks that something may be cosmic rays, particles from exploding stars, the same stuff that makes CMEs.
These things come barreling down through the atmosphere, and they sort of blaze the path through the thunderstorm that gets it all going.
Every year, 100 people die in lightning strikes in the United States alone. Dwyer is on the trail of a killer from outer space. He thinks he may find it in the Arizona desert at the Veritas Observatory, the domain of an old college pal, astrophysicist Scott Wakely of the University of Chicago. Their plan? To catch it in the act.
This is a cosmic ray coming straight down the pipe.
Wow, 10 nanoseconds, that's pretty fast.
The duration of this pulse is about 1/30 of an eye blink. Wow.
Cosmic rays hit the Earth from all directions. They're tiny, subatomic particles moving at close to the speed of light. When a cosmic ray hits the atmosphere, there's a massive release of energy that smashes the air molecules apart. This air shower moves so fast, it creates the equivalent of a sonic boom, a light boom.
So if my eye were very sensitive, much more sensitive than it really is, this is what an air shower would look like.
Yeah, you'd see kind of an oblong, bluish blob appear and disappear very quickly.
The telescopes detect an average of 250 cosmic rays every second.
This is the best looking one we've seen.
For Dwyer, the critical question is what effect air showers have when they hit a thunderstorm.
These showers are occurring about 10 kilometers up in the air.
Thunderstorms are like powder kegs ready to go off. And Dwyer thinks air showers could be striking the match.
Oh, that's interesting. That's about the same altitude that lightning initiates. And so if cosmic rays actually do initiate lightning, then this is what it would look like.
Invisible to the naked eye, all penetrating, a shower of particles passing through us and into our Earth. Pencils of blue energy raining down on us every second. Dwyer believes a typical cosmic ray is born in a supernova, the explosion of a dying star. For this cosmic ray, it's the start of a very long journey.
This source in particular is a galaxy which is about 500 million light years away.
I was going to say that's far, far away.
Okay.
If lightning is really initiated by cosmic ray air showers, think about this. Every time you see lightning and hear thunder, there's a physical connection between that lightning and a star that exploded halfway across the galaxy millions of years ago.
At close to the speed of light, the cosmic ray finally bursts into the solar system on the shores of Neptune. It's now just 4 hours from its destination. Meanwhile, in Florida, Dwyer and his team launch a weather balloon in preparation for a long afternoon of storm chasing. Dwyer is researching the physics of thunderstorms and the type of energy and radiation they contain. So his team are hunting lightning to try to capture readings that will reveal what's triggering it. Barreling past Jupiter, the cosmic ray is just 43 minutes from Earth. Dwyer spots possible thunderclouds on the horizon.
Florida is the best place in the United States to study thunderstorms. We get more lightning strikes per square kilometer here than any other place in the country. And in fact, this part of Florida, we're in southwest Florida, is really the lightning hot spot of the country. A little south of Sarasota on the Gulf side, that's where I am right now.
Well, the stuff that you're looking at right now is just starting to go, but the best electrical activity is on the storm south of you and down in Lee County.
Eric, I'm going to put you on speakerphone just a second. Definitely we can see what looks like some rain straight ahead, some decent cloud bases, but no sign of lightning yet.
There was a brief episode of lightning at about 5:15, just right kind of where you were.
Okay, by Fort Myers then, right?
You want to get down there as quick as you possibly can. I'd get off on the exit just north of the river there.
All right, so I'm going to take this north to 17, right? Yeah. Okay, so hopefully we'll pass right through that thing up there.
A massive electric charge collects overhead, like tension building in a rubber band. It just needs something to make it go. Dwyer homes in on the storm, while the cosmic ray passes Mars, homing in on planet Earth.
Hey, what's up? Can you hear me? Yeah, hello. Yep, I'm here. I mean, it'll work out for you. There were some positive cloud-to-ground strikes. The storm that we're talking about is starting to come down in intensity and starting to move offshore, so the day may end soon.
The cosmic ray smashes into the Earth's atmosphere and explodes into the Florida clouds. Only they're not in quite the right place to catch it. Today's storm chase has been a lightning strikeout. But if Dwyer's right, a star that exploded 10 million years ago, long before man walked the Earth, can still kill a man today. Weather on Earth controlled by the explosion of distant suns. But an explosion on our own sun threatens much more deadly consequences. A coronal mass ejection threatens everything in its path. And until we understand the mystery of the sun's corona, where CMEs come from, we can't predict when they will happen. The problem is, the sun's fiery brightness keeps the corona hidden from sight, except during a total eclipse. In China, the longest total solar eclipse of the 21st century is at hand. It won't be surpassed in duration until June in the year 2132. Totality here will last for almost 6 minutes, exposing the sun's corona and enabling study of this breeding ground for coronal mass ejections. This will be the 49th eclipse recorded by astronomy professor Jay Pasachoff. Pasachoff's chosen location is in the mountains near Hangzhou, over 900 meters above sea level and above low-lying smog that could impair visibility. But with just minutes to go, it's looking like cloud cover could ruin the main event. Hoping against hope, Jay Pasachoff keeps his team focused. As thousands count down to the total eclipse, astrophysicist Stuart Clark paces the expectant crowd at the foot of the mountains.
Now you can start to feel that the light is actually starting to go.
He's on the banks of the Qiantong River, where he's a guest speaker on an eclipse tour.
We'll see it go very dark very, very soon, and then hopefully just for a gap in the cloud, and we'll get to glimpse the corona. At least we can say we've been under the shadow of the moon for the longest eclipse of this whole century.
The sun is brighter now. It's clearing. 32? Yeah. 30 seconds.
At the last minute, clear skies. The sun smiles on Jay Pasachoff.
Filters off. 3, 2, 1. Diamond ring. Filters off. Corona. Diamond ring.
The moment of truth. The sun is eclipsed by the moon. Pasachoff's team now have just 5 minutes and 36 seconds to unlock its secrets. They're trying to find out why the corona is so much hotter than the sun's surface, where its power comes from. Most of their recordings are done through photography, and they discover something out of this world. The cameras search for faint ripples of brightness moving through the corona, possible evidence that its searing temperature is generated by waves. By converting these waves to sound, scientists can listen to the song of the sun. This is the sun's searing breath, hot enough to spit a chunk of the corona all the way to Earth. The waves start in the hot, dense gas near the solar surface. They wash across it, growing in size with crests millions of kilometers high. Then, like ocean breakers crashing on the beach, they dump vast amounts of energy into the corona, heating it to 2 million degrees Celsius. There is a way to hear the mighty solar ocean. These waves may be the hidden source of the corona's energy. If that's true, it can help them unlock the secrets of the corona, birthplace of CMEs. Then the spell is broken. All too soon, the diamond ring reappears.
Diamond ring.
Having revealed the corona in all its glory, the moon goes on its way. Pasachoff and his team have taken one more step on the road to understanding the corona's hellish temperature. Down at the river, the eclipse was less of a success. Cloud cover obscured the sun and its glorious crown. But the crowd is not disappointed, because the eclipse was only part of the spectacle they've come to see. The Qiantong River is one of around 100 in the world that has a tidal bore. It's a natural wonder, an extraordinary surging tidal wave that travels upriver against the current.
Now we're just ready to see the tidal bore.
The unusual shape of the river mouth creates the phenomenon. It funnels incoming tides into the shallow, narrowing river. The tides are created by the gravitational pull of the moon. But in an eclipse, the sun and the moon act together, and the pull is even greater.
Today, for the eclipse, with the moon and the sun in precise alignment, you get the greatest gravitational pull that you can possibly have on the Earth. So today we're anticipating quite a big one.
About 90 minutes after the eclipse, the river waters start to race. It's the world's largest tidal bore. In past years, it's reached heights of over 9 meters, and it can travel roughly as fast as a galloping horse at speeds of up to 40 kilometers an hour.
The situation for achieving a tidal bore is that we have a fast-draining river that's moving into the East China Sea. But the river is draining faster than the tide can actually move up it.
As the waters build, they're not ebbing away, and a giant wave is generated that then appears to change the direction of the river's flow.
So the tide effectively stalls, and it builds up more and more energy and more and more water until eventually it overcomes the draining of the river and then bursts up in this single tide.
Clark has borne witness to the physical power the moon and sun have over the Earth. Today in China, the effects were benign. But what if the sun's mood changed? How can we predict the impact of a coronal mass ejection, like the one that Richard Carrington saw in 1859? In a desert lab in Nevada, NASA scientist Bruce Turritoni is looking for clues in a block of ice from a century ago.
I am very excited. I'm on pins and needles right now.
He's trying to find the telltale chemicals left behind after a solar storm hits the Earth. So far, all he's got is evidence of a massive forest fire from the mid-19th century. But he's determined to keep looking for the Carrington event of 1859.
Hey, look at that spike. There's
Nitrate
a spike
spike.
in the nitrates. Is that the solar flare?
Well, it could be. It's occurring at the right time of year.
McConnell and Turritoni spot a big nitrate spike in September 1859.
There it goes.
They check for carbon, but it's clean. This is no forest fire.
That's the flare. Baby! Whoa, whoa!
Ice core experiments like these suggest the 1859 storm was around twice as intense as any solar storm ever recorded. It's a vital way of analyzing the solar storms of the past and a benchmark for storms of the future.
Well, I think you can revolutionize solar physics if you can find the solar flares that happen in the ice core data.
So far, scientists have examined ice cores from a couple of hundred years, but no one has found a bigger storm.
Now, there's absolutely nothing to say that another 1859 storm can't happen again. So the big focus is trying to work out how often they come about. And it seems as if it's once every several hundred years, perhaps once every 1,000 years. But right now, one could happen tomorrow.
The CME of Stuart Clark's imagination is about to impact the Earth. In Washington, D.C., a meeting held behind closed doors is wrapping up. A star chamber of scientists and policymakers discussing new research that paints a solar storm as the biggest natural disaster imaginable, one that would turn America into a third world country.
I think within a matter of a few days there will be a general desperation situation that people will come to and not understand that why haven't things been restored.
So what are we talking about? Lawlessness, breakdown of society? How bad does it get?
Well, it seems to me that this is the kind of event that could suddenly take a very advanced society back to a much
to the 19th century.
If a massive solar storm hit our planet, the first evidence for most of us would be a spectacular light display in the skies, a sign that it's already too late.
first thing you'd know about this taking place is that the aurora would burst into the sky. They would come from the north if you're in the northern hemisphere and just engulf the sky in what essentially looks like flames. So this blood red light. We're most vulnerable with the power grids today. They have these huge power lines that are just there waiting really for the aurora to put current into them. So the electricity induced by the aurora into the power lines comes barreling into the power station, and the transformers are simply not designed to cope with that much electricity. And it melts them, literally melts them. So the power grids these days work at peak efficiency, which means that there's no redundancy in the system, so no spare transformers, hardly any spare lines. So as soon as you start losing transformers, there's nothing you can do to get around that problem apart from rebuild them.
In 1859, the Sun gave warning that it has the power not only to sustain us, but also to destroy us. So far, that warning has gone unheeded. For now, we can only hope that the Sun decides to smile on us for a little while longer.